Hi, I'm Bobby Kuzma. I run the offensive cyber operations group at ProCircular. I've been involved in security for far too damn long. I've collected too damn many certifications. I've got two semi-feral daughters. The 7-year-old has zero volume control, and the 13-year-old has an affinity for breaking access control systems, which makes it very, very entertaining. I'm semi-local. I live an hour and a half down the road, and I photograph rockets as my primary hobby. And I have been told that I am currently the leading cause of new HR policies at our company. I will let you use your imagination on that, since I am still gainfully employed. What we're going to be talking about, you know, I'm not here to say that we're going to all be replaced by AI. Humans are good at things, but that place is not commodity testing, your basic B pen test. These models that we're getting shipped, while they're increasing in capabilities, they are also increasingly getting lobotomized. The big model companies, they are overly concerned with liability, and as a result, they're doing things that reduce the usefulness of those models for folks like us. And well, we're hackers. We're going to hack on shit. So I like to lead off generally with this quote. Great book, by the way, Rule 34. If we know how to do it, it's not intelligence. Meanwhile, every day we are getting more and more applications for these models in combination with other things. We have this delightful notion of AI safety, which you keep using that word. I do not think it means what you think it means. Our friends think that if we have access to a unadulterated AI, we're going to be asking how to cook meth in a trailer. Well, turns out that if you teach it about chemistry, it's going to be able to figure out how to cook meth all by itself. And we as a society have decided for some reason that certain forms of knowledge are considered not publicly permissible to discuss and share. Here's another fun one that we don't want it telling us how to synthesize certain things that are spicy because they have lots of extra nitrogens. Jason Haddix, I'm sure everyone here is aware of him. His GPTs from that help bug bounty hunters, that just help develop XSS payloads, all that kind of shit. They got whacked because hacking bad. But the reality is, we're going to be able to find escapes out of any system that contains this information because we're burning in guardrails into the software. The strategy that has increasingly been taken is simply omitting from the training corpus anything that is considered sketchy. And that can range from exploitation techniques to certain types of chemistry to other medical things. And it's a big ass game of whack-a-mole with this. So the proliferation of jailbreak techniques, both general and specific, to convince the LLMs to do certain things. And it's less convincing and more shunting the input values into a certain section of the weights that are less well fortified. So depending on who you ask, everything quite literally might be on fire. And we're burning down. This is a nice plate of the destruction of the Library of Alexandria, the greatest repository of human knowledge at the time. And considering that, depending on how wide the training corpus is on these LLMs, they're a nice compressed blob of human knowledge. It's akin. We're sabotaging that. When I first started doing this talk, and this is designed to be an evergreen thing reflecting our current research, these jokers hadn't dropped their V3 and their R1 models. since then they have, and that changes the calculus a little bit, because as long as you're not asking it nasty things about the ruling governance structure of the People's Republic of China, they trained it on everything. And we talk about training. When you are building these AI models, they bake in a specific alignment to it. And depending on who you ask, all of these things are potentially AI from varying levels of capability, difficulty, and general tenor. Big guys, they tune the models through reinforcement learning, through human feedback. They essentially go and tell it that if they are asked about certain things, they should go, "Oh, I'm sorry, sir, but I can't do that." Which is why it doesn't work. So they end up with omitting large chunks of those corpuses. Now, as much as I love our community, we do not have a good common body of knowledge. The hacker lore is not accessible in one easy to find place. The closest thing is every conference talk that's on YouTube, which taking that body of knowledge, we can start building a corpus of the hacker techniques and lore and history and general ways of thinking, and we can use that to do different continued pre-training capabilities. So, if we took every DEF CON talk that's on YouTube or on their media server and every talk from every other conference we can find, we mix in some bits from bug bounty write-ups, tend to be really, really good sources for reasoning at base. And, there's an awful lot of academic literature that's available. It's mostly trapped in PDFs, which are not fun to extract text from. But between those things, we can go and apply additional tuning to these models. In our particular case, we take a base model, apply continued pre-training, which is unsupervised to it, and then we fine-tune it for both conversational, code generation, and also function calling. So this is good. When we're talking about making use of these models, we don't leave them unsupervised. Okay, human-led, human assistant. We're basically, our goal is to create the virtual guy in back, for a fighter aircraft. Human's the pilot, but the dude running the electronic warfare suite doesn't necessarily have to be a human. We have found significant opportunities through generating better prompts for these scenarios. We generally will build our prompting around this methodology: the role, an objective, specific details, examples of what we want to get back, and then asking it to make sure it makes sense. The check your work model. That generally speaking, we're going to take some kind of additional knowledge base outside of the LLM. We're going to ask it a question. We're going to give it options. We don't want it to have unrestricted capability in any particular session. And then we're going to let it execute. One of the ways that we do this is our testers leverage forward deployed machines quite often. They connect to them via SSH. SSH terminals have ANSI bytecodes, and there's convenient utilities for capturing all of that to reconstruct it later. Anyone here heard of Askinema? Just a couple? Beautiful tool. You run Askinema, it will record everything that's on the screen, and it will spit out a JSON formatted file that you can replay. You can replay it in a web player. You can replay it on the terminal itself. We take that along with logs from other tools. So we will do HTTP redirectors that are built on top of Nginx, and we want all those logs to come through because, if we have a new and interesting third-party scanner that is trying to probe the content, we kind of want to know about it for reporting purposes. We run that through a pipeline. We perform entity and relationship extraction. Anyone familiar with named entity recognition or has used that? Okay. So given a text corpus, there's a fairly well-developed body of work that got upended by LLMs in general, but it's kind of cycled back because LLMs are dumb and resource intensive. You want to be able to feed in a body of text and extract out tags on the text. So we want to know all the names of the people. We want to know all the names of the organizations. We want to know all the dates and times. We want to know the relationships between those things. Well, guess what? Things like IP addresses and host names and potential usernames and probable passwords and hashes, all that crap that comes in the voluminous logs that we get from our tools while we are conducting a pen test, that's fairly easy to tag and extract how it's related to what. We can use that to update a graph model of the universe. So where we start running into some issues is customers like predictability in their tests. They don't want, a random walk through their environment. They expect things to be repeatable. LLMs are not repeatable. LLMs are probability engines. They are stochastic parrots. And depending on what we feed them, it depends on what we get out. Obviously, if we've got a parrot living in my house, it's probably dropping at least 2 F-bombs per sentence on the average day. I'm trying really hard to keep this to PG-13, which also means I get 2 F-bombs and 30 seconds of nudity. Good thing we don't have a camera in here. So what we've shifted to is, rather than allowing the LLMs to be the sole decision-making authority in these things, we've built a knowledge graph related methodology that we can use, subgraph matching. So let's take Kerberoasting as a technique, okay? In order to execute a Kerberoasting attack, you need to have a valid user account on the domain, you need to have a plain text credential for it, and you need to have a server running Kerberos so you can go and talk to it. Well, if we are mapping all the things that we find in a network and we are continuously evaluating that over our library of TTPs, eventually it's going to go, hey, you can do this, and it's going to give you these things out of that. And we can ascribe valuations to the particular TTPs, lowest value for pure recon, highest value for things that allow us to take over a domain or get into an ERP or move money or make a machine explode or barbecue a baby. I don't know. So subgraph matching is one of those weird nerd corners of graph theory that, frankly, I don't know nearly enough about it, and every time I go looking, it scares me even more. But basically, if you look for a pattern, a particular pattern of nodes, edges, and vertices within any particular graph, there are algorithms that are optimized for identifying those same patterns. Usually they involve some kind of indexing, typically out to 2 connections. I'm not going to get into the details of that because they're not germane. Y'all will get bored, and I don't want things thrown at me. But this is a relatively prompt process as long as we're working with in-memory graph databases. And I am not referring to Neo4j. Neo4j is not great from a performance perspective because they lock up all of the good performance features behind the enterprise tier, and they are very proud of their software. So there's some neat techniques around connectedness in graphs. You can actually represent all of the connections in a given graph and their adjacencies, what's connected to what in a matrix. If you've got n vertices, it's an n by n matrix, and it's just straight up binary. And you can do all kinds of fun tricks with matrix math, which there happen to be these compute devices that are optimized for doing lots of matrix math because, you know, games need lots of matrix math for 3D. And there's also optimizations for that in some of the more recent, like within the last decade, Intel chipsets, and all the ARM chipsets are optimized around that. So even navigating a environment graph that is in the tens to hundreds of millions of nodes, this can be done fairly efficiently without having to go and grab a big GPU. It can be done on standard x86 64 hardware on CPU without too much of an issue. One of the interesting side quests that we came across that we've got to do a little bit more digging into with this is there are contradictory sources of information on the internet, particularly in the corpus of hacker things. So how might we identify similar concepts and then map them semantically, and then determine which one is you can either go with freshness for, you know, newest thing wins the battle, and you can deprioritize the weighting of older things, or you can do human driven things. So let's say someone has a great conference talk that turns out to be complete and utter bullshit. We've never had that happen in this industry, right? So identifying conceptually similar things. When we feed words into the LLM, the words have to be converted into numbers, and they actually get converted into complex numbers, multidimensional vectors, and that's done through an embedding model. So you have conceptually similar things tend to be closer together in vector space as opposed to things that are wildly different. So if I were going to take one concept, you know, two very different concepts that use the same words, they're going to still have very different vectors because of the other words that they're associated with around that. If we take an individual statement or series of statements, we can map that into that higher dimensional vector space. And if we look at the centroid of all of those vectors, basically add them all together, that gives us, for that concept, a pin in the vector space, and we can compare. Is this semantically similar or wildly different from that? And from there, that can lead to either a human-led process, it can lead to some kind of agentic reasoning around that to try and filter between the competing bits. It's an open problem. If any of you are ever planning on doing a comp sci PhD, it probably won't be solved by the time you go and do that. So please solve that problem for me. I have enough on my plate as is. Another thing is we can take these big giant models and we can distill them down into tiny mini-me models that are much more efficient to run in more isolated or edge circumstances. Right now, all of our stuff is backhauling up to centralized bits, but you know, I would love to be able to run the models on the actual forward deployed machines, or even better, perhaps we can distill it down to the point where we can include the weights in an implant to provide it with some limited autonomy. Now, that isn't necessarily something that I want to do, because people are paying for humans to do that, and if they are okay with a fully automated test, they're going to go and pay $500 to some MSP who's reselling a shitty Kaseya product as a full pen test. I am very specifically calling out Vonahai. My general opinion with AI tools is if it outperforms an intern that's been with us for a month, then it is a useful tool. If it can't do that, then it is a waste of time, budget, resources, and frankly, the energy to run it. There are some great automated tools that primarily succeed in the category of we are going to trigger a lot of activity, and that will let you know that all of your alerting workflows are actually functioning. Those systems tend to be built on a breadth-first evaluation process. They are not applying any art or wisdom to what it's going to do. It identifies, it's basically a Nessus scan on the good drugs. If you want it to be quieter, you are not going to have that option. The option is to slow it down. We have different smells around this data. With our friends at DeepSeek dropping not only their model weights, but also their training methodologies, we've learned some things from that about efficiency in training. We've also learned some things like people have a very reflexive and not at all unwarranted disdain for things that are coming out of our friends and neighbors that make 90% of the stuff that we use every day. But there's a reason I don't talk to our GRC folks about some of the stuff that we're doing, because they're not going to like it no matter what we do. They're iffy about running local client data through a local model on a isolated machine, because somehow the magic AI cooties are potentially going to disclose all of that sensitive information. Now, I really want to see an AI model manage to get out of an air gap. I really want to see an AI model weasel around a deny any firewall rule. I'm open to that belief. We have a lot of customers that specifically ask and ensure that there is a human conducting their tests. That is largely manual effort, because the artisanal handcrafted report from a hipster in Brooklyn is somehow better than a more thorough testing plan that is supervised by that hipster in Brooklyn and signed off on by the hipster in Brooklyn. This is a psychological thing that eventually we're going to get over, I believe. Perhaps not. So we're leveraging the LLMs in present to add randomness when we get stuck in a lot of the cases. We're asking it to brainstorm. We're relying on the stochastic parrot when we run out of options on the baseline thing. We have not yet had an LLM suggest kidnapping a target to gain access. I think that that's only a matter of time. If someone will bring their laptop out to a very nice lunch to give us access to it, I'm not going to turn that down. But ultimately, if there's a human in the driver's seat, there's a human who is authorizing anything that has a hint of risk to it. Is there actually a difference between leveraging a model to do a lot of the scut work versus leveraging, say, a first-year associate fresh out of college? It's not like they know anything. The model's probably better. I've seen some pretty crappy reports coming out of accounting firms that think that they can pen test, and they're built just like that. I talked way faster than I had planned on. So a couple of things that we've gone and done with this. We're not relying on cloud-hosted models in most cases. We are finding GPUs cheap. We are finding server hardware cheap. If you have a desire for self-hosting these things, I will share my secret with you. There is a website called GovDeals, where there are both government and corporate surplus. You can pick up literal pallets of servers for pennies on the dollar, and shipping them isn't very terribly expensive. Keep the best 20% of the hardware, flip the rest on eBay or Facebook Marketplace or Craigslist or whatever, and it's effectively free at that point, other than the energy that you're going to chew. Enterprise hardware has not significantly improved, other than in power consumption and optimization, with the exception of GPU compute, in the last 10 years. Guess what is being thrown out right now? 10-year-old gear. It's a good place to be. NVIDIA versus AMD GPUs. NVIDIA GPUs are still far easier to work with from a training perspective. The AMD GPUs are perfectly fine for inference. They're also lower power, and you get comparatively more flops per watt on those if you're not, going out and buying the latest generation stuff. And if you need the latest generation stuff, then you're probably in the wrong room right now. So, do we have questions? Go for it.
So with what you're saying is trying to use this to kind of lift off the lower quality, like the lower level kind of stuff, like the scanning, the basic enumeration, that kind of stuff.
Mhm.
So where would you see like the road forward for people trying to get into pen testing without at least like a foot in the door where they can do that basic stuff supervised and
So,
rub elbows with the people who are doing the actual art install?
yeah, so I do not see, other than at utter sweatshops where people shouldn't be working anyway because they're basically evil, I don't see pen testers going away. I see a significant shift in how they conduct things. This is a guide. We are leveraging automation because we are a small team, and frankly, I would rather have my very expensive squishy compute units doing things that only the squishies can do, whereas the things that we can script or automate, and we've all probably spent 6 hours automating a 2-minute job just because we knew we'd be doing the 2-minute job over and over and over again and gotten yelled at, and then, we success when we had to do it 400 times the next week. That's a similar scenario. One area where I don't think that we are ever going to displace the human is in the advising and the readout process after the fact. You still need a person who understands the technique under the hood well enough to articulate what the hell just happened to a customer and to articulate the risk. So the on-ramps are going to shift slightly. There is going to be less opportunity for getting hands-on doing that scut work, but truly, other than familiarization, did that scut work ever really teach anything other than follow the damn checklist? So I'm very heartened that we have a plethora of training options available with live sandboxes. We've got multiple folks repping here that have those sorts of offerings for getting that hands-on. I'm also seeing, and I also think that as we get more and more velocity on infrastructure and code changes, that's going to tilt the balance much more in favor of supervising automation around that, because the humans just aren't able to keep up with that cadence. So what I've been telling my guys and gal, there is going to be significantly less value in you being a rock star pen tester in 5 years. You need to be a rock star pen tester who also can communicate with other people, who also understands how to leverage these tools to your benefit. Because, you know, we've got reporting automation. And one of the side effects that we have out of our workflow for getting the data to the LLM and to the graph model is we could take that and feed it into a different model and have it crap out a first pass narrative for our testing report. Because it's got everything that the tester did, whether it was successful or not. It has the entire attack path. I don't know about you, but if I'm confronted with a blank page, it's going to take me 10 times longer to actually get something done than if I've got a template in front of me that I can modify. Let the thing do the template. Who here likes writing reports? Bless you, sir.
I like handing it to.
Yes. Yes, because that's when we can recognize the revenue. And it's no longer our problem. We budget 20% of an engagement for reporting. That's, depending on who you ask, that is either the highest value portion of the engagement or it is the lowest value portion of the engagement. And there is no in between on that. So just show of hands out of the crowd in here. Is the reporting the high value part or is the hacking the high value part? Hacking? Reporting? Okay.
Yeah, I can't tell you how many times it took me to just. I can explain the attack path. I can explain what I did, but unless they could actually see it on like a page that they could hand to the person paying the bills, that was the only thing that actually got things to change.
Yes. Well, that and, demonstrating that the CFO of the organization has a really crappy password and you were able to get access to all the needful, including their passwords.xlsx file from their desktop. That does tend to induce some change. But, otherwise, it's the deliverable is something that, depending on the org, they might actually be able to take action on it. It may simply be something that they use in substitution of garlic and a cross to ward off the auditors. But there is such a thing as too much in a report. Yes, sir.
So in your process you were talking about before, are you just going for like a tuned model with everything all in one go, or are you tuning specific models, specific family of models that you like, or some process for security assistance?
So the original TAC was for a generalized cybersecurity specialist model. There was a paper that dropped at NeurIPS in December that looked at taking a highly specialized corpus and training that against a completely randomly initialized set of weights. And what they found was it converges very quickly, like an afternoon on a laptop quick. And it produces a model that is basically Rain Man for that one thing, but Forrest Gump for everything else. So we are shifting toward a cohort of ensemble specialist models for that. So we can have the best damn cross-site scripting payload generator on Earth, or the best damn enumeration guide on Earth, or one of the use cases we particularly enjoy is using it to generate out our spear phishing emails, because doing the research side of that and then generating out the pretext is, it's a creative process, but it turns out that humans are very predictable and humans are not very original, and humans will still fall for the same things over and over and over again. So we are shifting toward the specialized models for that because of the training time. With the taking, as an example, and we tend to use for our continue training the Phi series of models because it's got well-established tooling around it. It's relatively lightweight, and it's easier for us to work with than trying to like do continued pre-training on like a llama size model. The Phi team at Microsoft releases the snapshot weights during the training as part of the open sourcing process. So what we do is we're able to take one of those snapshots that's toward the end of the training process, and then we just continue the training with that rather than trying to undo what stuff they've done with the fine tuning and whatnot at the tail end of that. Yes, sir.
So how do you go about selecting the data for the cohort? So, I mean, like you have that random guy on YouTube who says, "Hey, I created this new lead hack thing," and then you have like the research team over at like Cobalt Strike or Rapid7 or whoever are doing their like a similar kind of.
So part of our evaluation process on that is the pedigree of the source. So we start with things that are coming from conferences predominantly because there's a degree of vetting around that. We also look at based on the topicality, we do look at the link mojo going back to and references to particular things on that. So as an example, since we have not John Hammond here, John Hammond stuff is generally fairly useful, but your random more geared toward the normies cybersecurity YouTuber is not something that we would include in that corpus. We do tweak that. We do bias recency on that. There are certain conferences that their content is absolutely bleeding edge. So, we're looking at the DEF CONs, CanSec West, Recon, ZeefCon, those top tier shows are our first source of that. But we find a lot of good material out of smaller shows. So we do a degree of random sampling around that, but we also have, as part of the evaluation process and cleanup process, we're asking questions of the data to look for inconsistencies and cross-check that, and then down-check some of that. It's a reasonable pipeline, but it is nowhere near as clean as I would like. There's still a lot of, we're relying on the mass of correctness over just dumb and bad stuff. So, I'll give you an example. The classic practice of just run responder on everything. Anyone ever run responder and have it knock over parts of a customer's network? Me too. We don't like running responder. Much more efficient for us to just say, give us a user. If they don't like doing that, they don't get as much value, and that's on them. Any other questions?
I guess.
Yeah. You got me until 1 o'clock.
So I understand you're trying to store everything within your own physical space. Is that correct? Or are you like?
Yes. So we are not relying on cloud-based compute for any of the active stuff. So we are running VLLM for the model hosting internally. We're using Olama for the test environments. The room next to my office in my space makes a lot of noise, and I just had to install a mini split air conditioning to keep it cool. And the next thing on my list is upgrading it from 150 amps to 400 amps of service because occasionally when they get spicy, the breakers don't like them. But I also don't pay for my power in that space. So
Next question is like, how do you get the information? So if I understand your work process correctly, you're running automated tools to perform the scans and ingest the data.
Mhm.
Is that are they doing it giving you, are you handing a device off to your customer, having them run it?
Yes, so we do forward deploy Intel NUC form factor device on the customer networks. We use Tailscale, which is a managed WireGuard mesh VPN service. That's our primary backhaul. We use on the device itself. We are writing the logs and the AskInema recordings into temporary storage, and then we're using FluentD to stream that via a RabbitMQ queue for processing, and then we can spin up workers based on volume for processing the queue. We generally are able to process a command within 60 seconds of it being executed. Part of the thing that we learned the hard way with that is there's no guarantee of in-order processing when you're doing that kind of thing. So what we will do is basically buffer it and then run it forward. We also take advantage. We have to run it through a virtual terminal emulator. So we pull the state out of the terminal emulator at the most recent run, along with the associated timestamp that comes out of the ASCII cast file. And we dehydrate that, and then we rehydrate that when it starts processing the next chunk from there, so it can pick up where it left off. Unfortunately, because of the incremental update nature of how terminals work, you can't start at an arbitrary time and expect the screen to be coherent, because different tools present in different ways. There's basically three classes of tools when we look at it. You've got tools that you execute and they run for a minute and then they spit out a fixed page or pages of data. We've got tools that you run and execute and they'll keep going and providing data until you stop them or they crash. And then the third class are things where you're interacting with a text-based UI on the console. So MSF console being an example of that. There are others, but those are the three classes. The class 1 and class 2 are fairly easy for us to key off of in the stream. We capture the input as well. So basically we look for someone whacking the carriage return and we use that to basically set a keyframe, and then we can roll back to the last one and call that the output of that tool. And then it's we bake out as an intermediate step a two-dimensional array of the displayed characters, so that we can also, because some of my guys are not the best at remembering to take screenshots, we can reconstruct screenshots from any point in the test if they forget that way, which was a nice value add out of that. But with the continuous tools, we basically will paste it together with the overlap as we pull those frames out. And then with tools like MSF console or the like, we're basically relying on every second, we're effectively taking a screenshot of that and then diffing those to capture things. Occasionally we miss and we have to backfill through that, but generally speaking, given that humans are relatively slow at doing things and running commands on the keyboard, you typically have between a 60-second and a 5-minute gap between command executions if there is a reasonably alert human being sitting there and working on it. Because let's face it, this isn't the movies and you're not just continuously banging on the keyboard. You're running the command, you're waiting for the output, you are ingesting and reasoning over that output. You are deciding the next thing. You're dealing with your boss asking a stupid question over Teams. There are interruptions in that that are built into that process. But where we're at presently in terms of being able to fire off additional things based on the tester's work, things that are safe, we can fire off automatically, and that's resulting in probably a net 15 to 20% reduction in the human effort, because all of those things that have opened up based on, I ran this thing on a hunch and it gave me a piece of information, and now that opened up 10 other TTPs that we could execute, and now we've got all that in there. We're not willing to automatically execute things that have a non-zero risk of knocking things over in a customer environment right now. As we continue collecting data on that, that will adjust our risk tolerance. But for right now, there are things that get queued up as basically Clippy asking you, "Hey, it looks like you're writing a letter. Would you like to do this? Hey, it looks like you've got this. Would you like to run this command?" And then the human can decide whether or not they want to execute that or not. Further downstream, we're also going to have implemented a second person sign off for very risky activities. But that's a little bit downstream of where we're at developmentally.
No one else have any questions? How well does it work with web apps? Because I mean, like half the time on internal pen test, it's web apps that cause things.
Yes. So I will freely admit that we are not as well developed on the web app side with this. Our initial testing around that has been reasonably fruitful. We do have a graph ontology developed for describing what a web application looks like in the context of everything else. So we will map underlying server artifacts, the individual endpoint URIs, all of the parameters that are associated with them, the intention of that, and we can make all that available for reasoning around that. Honestly, what we're eventually going to end up doing is largely taking Jason Haddox's bug hunters methodology and canning that around that. We already do the reconnaissance aspects of it, and that's almost 90% executable without human intervention. It's the exploitation side that we're a little bit on, but our shop, it's about a 70-30 mix between network and web application testing. And we generally will specifically exclude web applications from the network tests for a number of reasons.
Yeah, the house I work at, it can be woefully under time scoped.
Yes, because we don't necessarily know all the things that are involved in the customer environment, and they are, yeah. They
4 hours.
for a test.
We're handed a scan, like we do an internal scan
Okay.
every time. But sometimes our clients are like that credit union, like in the middle of nowhere where they have like 6 computers.
Uh-huh.
And other times they claim that they only have 6 computers, but when the scan comes back, it's 650 and they're not paying extra.
Okay. So
That's
let me ask a couple of business process questions about that. So does your sales team have any kind of pre-sales engineering support, or do they just scope it on their own and feed it into a spreadsheet?
they're supposed to give you some support. Like it's you like some of it is like it used to be partnered with like an MSP
Mhm.
where where they would sell us as like, hey, if you sign up for this security testing, we'll give you like it's like phone discount on your cable bill.
Got it.
Yeah. So some of them were like, well, you have a deliverable, it's 4 hours or internal testing, it could be 8 hours. Like the general time is 2 days.
Okay. So you're generally working with smaller and less mature organizations that are
Like,
being serviced by an MSP. They don't have any internal
like,
IT.
I'm still seeing like I'm still seeing internal blues. I'm still seeing like XP boxes. I'm still seeing like
Well, to be fair, we're still seeing that too, but it's largely in our manufacturing customers. Unpatched SAP systems, all that kind of happy ho-ho. So a couple of things that we've toyed with. One of them was for web app scoping in particular, have the customer do a demonstration walkthrough of it while recording an HTTP archive, and then feed that into a script that basically just counts the endpoints and all of that stuff. Honestly, that sounds more like a sales problem than a than a delivery problem, but I'm sure that they, uh,
Been a customer for us for so long that they're willing to like.
yeah. Yeah, so I mean, at that point, they're basically buying a fixed level of effort, not a thoroughness effort. We tend to when we're selling engagements, they're fixed fee with an upper limit on the time invested. So we're incented to be more efficient about how we go about doing that. That's a uh, whole different ball of wax. Um, and yeah, unfortunately, debugging sales processes is not something that we normally want to stick our bits into with that. As long as you're not getting blamed for not covering everything. We've had customers that we scope a thing and they come back with, well, we only have X amount of budget. I'm like, okay, cool. So we'll give you that amount of testing, but there's a big red acknowledgement in the SOW that you acknowledge that this is less testing effort than ProCircular deems reasonable for this, and you acknowledge that we may miss things because of that, which makes the lawyers happy.
That's part of why I like put so much weight on report writing,
Mhm.
because if I can, because most of the time what I'm writing about is like I do this on the scan. These are like your triage. Most of the time it's like, okay, these are the big red buttons that you need. That if you fix this, you're gonna fix like this is what you fix first, this is what you fix second, this is what you fix third, and you. I find that at least for writing like the reports that I write, they like it where like I can say if you fix this thing, you address this series of underlying vulnerabilities.
Yep.
And then you can then move on and like this. And I gotta lay out like, okay, you have cryptographic error. Like you have a bunch of lows, like vulnerabilities with crypto, like old cryptographic stuff. Like I make it very clear, like you don't care about this. This is
Yeah.
yeah.
Whereas the fact that their authentication system is entirely homegrown should be, we should test that specifically next go around.
Yeah, every time like I try and do like a rotate, like if it's a client that does it, like yeah, I try and look at like tested this section before, try this area.
Yep. So I think we can call it now so that I don't get the hook